Hi everyone, this is Miss Dove bringing you the flipped instructional video for identifying equations. So our goal of this video and section is to determine whether two numerical expressions form an equation. Before we start, I want to review and let's remember how we evaluate numbers with powers, our exponents. So remember that any base, big number, to a power means that you're multiplying it by that number that many times. And you're just going to do a series of multiplication. So 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. You could also do 2 times 2 is 4, 2 times 2 is 4, and then 4 times 4 is 16. So either way, you're going to get 16. I'm going to change my color. Sorry about that. 4 to the second power is 4 times 4, which is also 16. But just because those numbers are switched, it doesn't always work that way. I'll show you down here on this one. So 5 times 5 times 5. 5 times 5 is 25, and 25 times 5 is 125. Okay, and then just to show you what I was talking about, 3 to the fifth power, I switched those. This is going to be 3 times 3 times 3 times 3 times 3. So I know that's 9. I'm going to pair those up as well. 9 times 9 is 81, and then I can't forget about my 3 over here, 81 times 3. And I need to do that over here on the side. 3 times 1 is 3. 3 times 8 is 24. So the value of 3 to the fifth power is 243. So just remember that switching the base and the exponent does not always give you the same answer. Over here, that was a coincidence. So there is evaluating exponents. Now, let's talk about what an equation is. When two expressions form an equation, that means they have the same value, okay? So an equation is a true statement, which means one expression equals another expression. So let me show you what I mean. Let's decide, is this a true equation? Yes or no? And so what we have to do is we have to solve each side. I'm going to put a line here to remember that they're separate. And at the end, we're going to decide, are they equal or are they not? Remember that we do have to follow our order of operations, which are parentheses, exponents, multiply or divide, whatever comes first, and then add or subtract, whatever comes first. So over here, I have some exponents that I need to figure out first. So 2 times 2 times 2. And then I'm going to end up multiplying that value by 3 times 3. Okay, 2 times 2 is 4, 4 times 2 is 8, and 3 times 3 is 9. 8 times 9 is 72. So if I get 72 on this side, then this will be a true equation. I would put an equal sign between them. If not, it's going to be not equal to. So we're going to do our parentheses first. 7 plus 11 is 18. And then 2 to the second power is 2 times 2, which is 4. And then I need to solve 4 times 18. So 4 times 8 is 32. 4 times 1 is 4, plus 3 is 7. So look, both sides equal 72. These two expressions do form an equation because they balance. Both sides are equal to 72. Okay, so yes, they do. Okay. So for practice problem 2, we're going to determine whether the expressions form an equation again. So we're going to either use an equal sign or a not equal sign at the end. So for this one, I wanted to review how to do this and also fractions. Remember, we do have to always follow our order of operations. So over on the right, I have to do 1/4 to the second power. Sometimes you're going to see it like this. Sometimes this will be in parentheses. Either way, I have to do 1/4 times 1/4. Okay, so I multiply the top numbers, multiply the bottom numbers, and so I'm going to drop 3.5 down, and what I'm going to be doing is subtracting 1/16 from that. Okay, we can choose to leave this as a mixed number if we would like, but we do have to have a common denominator. And so to do that, I can multiply this times 8, which means I have to multiply my numerator times 8. So this becomes 3 wholes and 8/16, and I'm subtracting 1/16 from that. So my answer, and I'm going to bring it all the way back over here so that I have room on this side. I'm doing 8 minus 1, 7, and your 16 stays. You do not add or subtract your denominators. They always stay. And then the wholes, it stays as 3 because there's 0 wholes over here. 3 minus 0 is just 3. So this is the answer to my left expression. Let's go ahead and evaluate my right expression. Now for this one, I am going to be doing 2.5 times 2.5. However, when multiplying fractions, they do have to be improper. Okay, so in order to do that, I'm going to, let me grab a different color real quick. That won't work. I'm going to do red just for a second. You are multiplying your denominator 2 times the whole number, which is 4, and then you're adding the numerator to that. So 2 times 2 is 4, plus 1 is 5. It's going to be the same thing over here because they're the same fraction. So 2.5 as a improper fraction is 5/2. So let me draw a line so I remember. So I'm doing 5/2 times 5/2 in order to complete this right here. So again, multiply the top, multiply the bottom, and that is 25/4, and I'm going to be subtracting 2 wholes and 13/16. Now, because my first number is improper, I'm going to go ahead and make my second number improper as well. And then I also have to have common denominators. I know that I can easily make 25/4 into 16ths multiplying by 4, and I have to also do that on the top. So I'm going to come up here to continue. That's going to be 100/16 because 25 times 4 is 100 and 4 times 4 is 16. And then I'm going to make this improper. Remember that you do 16 times 2, that's 32, and then you add 13. That is 45. So I'm subtracting 45/16. Okay, so again, my denominator doesn't change. 100 minus 45, if you think about 100 minus 50 would be 50, but I'm subtracting 5 less than that, so it's 55. Okay, and then my final answer, I have to now make this back into a mixed number. In order to do that, I have to do division. So I'm going to come up here. 16 goes into 55. Let's see. I know 16 times 3. That's 18. 48. So that's as close as I'm going to get. So 3 wholes, 48. And my remainder, I have to do some regrouping here, is going to be 7. Look at that. 3 wholes, your remainder is your numerator, and your divisor is your denominator. So much work. Hopefully you followed me through all of this. My final answer for the right side is 3 wholes and 7/16, which is exactly what I got on the left side. So determine whether they form an equation. They do, so I would use an equal sign, and it is a yes. Okay. If you stuck with me through that, great job. That was a lot of work. So to review, we determined whether two numerical expressions form an equation, and your next steps are to look for a flipped follow-up session, request a target teach if you need some additional practice, attend Help Lab if you need extra support, and have fun.